Hello students, welcome back. The topic that we are going to learn today is binomial theorem. So first of all, we need to know that what exactly is binomial theorem, then we will learn how to use binomial theorems. Okay. So a binomial theorem is a way of expanding an expression that has been generally raised to inconvenient large power. Now what does inconveniently large power means? Now let's suppose we have two terms a plus b power n. Now this n, that is power, can, let's say, sometimes it's inconveniently very large. It can be 7, 8 or so on, and such powers are not easy to, or such expansions are not easy to memorize. So we use binomial theorem to expand the expression so that we can easily solve such expression without learning every terms of it. Okay, formulas. So this is basically the general expansion of binomial theorem. A plus b power n is equals to a of n plus n into a n minus 1 b upon 1 factorial. Now if you see this, we have started with the highest power of a that is n, and we have reached till power bn. We have reached till b power n. That means with each step we have reducing the power of a and we are increasing the power of b. Alright, formula is a plus b power n is equals to summation k equals to 0 n nk a power n minus k b of k. Now this nk means NCR formula, or we say the combination formula. If you just look at the first term of the expansion, a of n, then the second term 1 factorial. If you just look at the denominator, we have factorial. This exclamation mark is basically called factorials. Alright, so first of all, before starting and before solving an example, we will first need to know that how to calculate this factorial. Alright, now factorial is the product of all positive integers from the given number to numbers till 1. Now what does that mean? For example, I need to find out factorial 3 factorial, let's say. So how to find out the 3 factorial? It says that product of all positive integer from the given number to numbers till 1. Now I need to find out 3 factorial. That means starting from 3, alright, ending till 1, all the numbers in between will be multiplied. As it says, it's the product. That means multiplication will happen, or we need to multiply the numbers. Alright, so 3 factorial means 3 factorial into 3 factorial means 3 multiplied by 2 multiplied by 1, that is 6. Now let's say we need to find out 4 factorial. So 4 factorial will be 4 multiplied by 3 multiplied by 2 and multiplied by 1. Similarly, if we need to find out 5 factorial, now how we will find 5 factorial? We'll start with number 5 and all the numbers in between till 1, we're going to take multiplication of all those numbers. Alright, so 5 into 4 into 3 into 2 into 1. So that is how you find out 5 factorial. Okay, so now we're just expanding this expression by using binomial theorem. Alright, so the expression is x plus y power 4. Now out here the n, the power is 4. Alright, so we will be using a general expansion first, which is this. Okay, now as I told you earlier, in this expansion what we used to do is we take the highest power, we take the first term with the highest power, that is n. With each step we start reducing the power of a and increasing the power of b. See, as you can see, there is no b, b1, b2, b3 and till bn, till we reach this point. Alright, out here n is equals to 4. So let's just expand this expression by using binomial theorem, the general expansion. Now for first term, the first term means a power n, that is x power 4. Now I said that we will be starting with the first term with its highest power, that is n, So the first term was x, and the highest power that was given to us, or the power that till we need to expand that expression, was 4. So n equals to 4, x power 4. Now second term. For second term, what we are going to do is we're going to draw this 4, alright, down 4, and we're going to reduce one power, that is 4 minus 1, x, and we're going to introduce b, that is y, upon 1 factorial. Alright, so what we have done out here is that I have just written 4 multiplied by a, that was x, 4 minus 1 b was y, upon 1 factorial. Solving this expression gives me 4x cube y. Now as you can see, in the last step I have written x4. We have solved x4. Within the second step, the power of first term reduces, and we have introduced the second term. Alright, so it was x4 in the first term, now it's x cube. Okay, so moving on, we are now moving on to the third term. Alright, so n into n minus 1 a, n minus 2 b square upon 2 factorial. Now see, 4, this 4 minus 1 x, 4 minus 2. Now in the previous step we have subtracted 1, now we will be subtracting 2. So 4 minus 2, power of b was initially the term, second variable was 1, now it will be 2, upon 2 factorial. So 2 divided by 2 factorial. Alright, see, power of b was 2 square, power was b was square. Alright, so 2 divided by 2 factorial. Now 2 factorial is 2. So as we move on, we just solve this expression and we get 6x square y. Now you can see, as I told, starting from the highest power n, reducing power of first term in each step, and increasing the power of second term in the increasing the power of second term gradually. So at this point, as you can see, my power of first variable, that was x, now it's a square. The power of second variable, which was y, is square. 1, 2, 3 and 2. So we know that as we move on towards the fourth term, this x square will be now 1, and y will the power of y will be increased. Alright, see, now 4 minus 1, 4 minus 2, x, 4 minus 3. Earlier we did 4 minus 2. Alright, now 4 minus 3, y cube upon 3 factorial. So the power of the second term will be the same number, the same power will be written with the sign factorial in the denominator. So y cube 3 factorial, y power 3 factorial. Alright, now as I just solved it, I find out the answer that I got is 4xy cube. Now as you can see, if you just remember, in the earlier step the power of x was 2, now it's 1. The power of y was square, now it's cube. Now in the last step we know that the power of y will be 4, and we need to expand the term till x4. Alright, so the n was 4 out here. As we saw that earlier, we started with the maximum power, that was x power 4, and we'll end up at y power 4. Alright, so final step, if you just see n minus 1, n minus 2, Alright, this n minus 3, that is 4 minus 3 x 4 minus 4 y power 4 upon 4 factorial. So the power of y was 4 divided by 4 factorial. Alright, so just write it down again. Okay, now as I solved it, anything power 0 is equals to 1. Okay, so anything power to 0 is 1. Out here it's 4, 3, 2, 1 divided by 4 factorial, which is 24. So 24 divided by 24 gives you 1. X power 0 is also 1 and y equals to 4. So the complete expression that we got is x plus y power 4 is equals to x4, 4x cube y, 6x square y square plus 4x y cube plus y4. Alright, as I said, we'll start with the highest power of x, that is n. Out here it was 4, and we'll apply and we'll move, or we say that we end up at the y power 4. We'll start with x power 4 and we'll end up with y power 4. So with each step, as you can see, the power of x is reducing, 4, 3, 2, 1, 0, and with each step the power of y is increasing. The power of x was reducing and power of y was increasing. Now out here it's y power 0, that is 1, so I haven't written y1. Alright, so or you can say y0, 1, 2, 3, 4. See, x power 4, 3, 2, 1, 0, y power 0, 1, 2, 3, 4. So we started with x4 and we ended up at y4. Thank you.